Hello, this is Mr. Miller and welcome to another pre-calculus video. In this video, we're going to study real-world parabolas. We're going to see how quadratic functions occur naturally in physics and the world. So, we're going to study projectile motion. Projectile motion is when you throw an object or shoot an object into the air. And from physics, we have a formula for the height of the object as a function of time. So if you tell me the time t, we can put it in here and calculate the height h. So h equals minus 16, that's a constant from gravity, times t squared plus v0t. v0 is the initial velocity, so it's how fast you threw the object up or down. And h0 is the initial height. From what height did you hit the object or throw the object? So v0 is positive if you throw it up, negative if you throw it down, and v0 is 0 if you just let an object go and fall to the ground. Alright, so let's take a look at an example. A ball is thrown upwards with initial velocity of 40 feet per second from a height of 5 feet. That's v0, feet per second, that's speed, 40 feet per second. And this is the initial height. So let's go ahead and put these in for v0 and h0 in the equation. So we get h equals minus 16t squared plus 40t plus 5. Okay, it's a quadratic function. It has a t squared in it. And the graph of this would be a parabola. Alright, so we're going to use this function. We want to know the height of the ball after 1.5 seconds. So if t equals 1.5, we get h equals negative 16 times 1.5 squared plus 40 times 1.5 plus 5. Grab a calculator and do it, you'll end up getting 29. So after 1.5 seconds, the ball is 29 feet above the ground. Alright, let's take a look at a couple more examples. So, same kind of idea. We're going to write an equation and find the value at a certain time. In this first one, the initial value of velocity is 120 feet per second. So that's v0. And the initial height is 4. So let's use the equation here and to write this. So this is h equals negative 16 t squared plus, we're going to put 120 in for v0, so 120 times t plus h0. That would be plus 4. Now, we can find the height whenever we want, but we're going to do it at 2 seconds. So let's put in 2 for t. So h equals negative 16 2 squared plus 120 times 2 plus 4. Alright, if you do all of that, you should get 180 feet. That's how high up it is. Okay, on this one, initial velocity 70, initial height 5. Here we go. h equals negative 16t squared plus 70t plus 5. And if we want to know the height at 1.75 seconds, we're just going to put that in. So h equals negative 16, 1.75 squared plus 70 times 1.5 plus 5. Alright, all that mass equals 78.5 feet. Okay, so let's take a look at the next one here. Alright, this time we have a nice graph drawn for us for decimals. It says a rocket is shot upwards from the top of an 80-foot building with an initial speed of 100 feet per second. Its height as a function of time has been graphed on the right. Alright, cool. Write an equation for the height of the rocket. So we're going to write an equation for this parabola. Here we go. We have h equals minus 16t squared plus v0t. This is the velocity right here, 100 feet per second. Alright, plus h0 plus 80. That's the equation for that parabola. So how high does the rocket fly? Well, we can use algebra to find that. We're going to do that in a second, but we have a graph here, and I just wanted you to look at the graph. So looks like it's in between 230 and 240. So I'm going to say about 235 feet. When will the rocket hit the ground? Well, that's this x-intercept right here. Rocket hits the ground when h equals 0. That's the height of the ground, 0. So the height equals 0 at 7 seconds. I didn't use this one because this is a kind of before the rocket was fired. It's a negative value of time, and this one really doesn't make sense in our problem. Only this value does. All right, use your equation to find the height after 2 seconds. Okay, this is kind of like what we did several examples of. Negative 16 times 2 squared plus 100 times 2 plus 80. And I get 216 feet. That would be the height right here at this point right there. And we see it makes sense. That's about 216. That's the point in time we're asking about. All right. Now, this is the last part of our video. Here, we're going to do some really awesome math. No graph this time. So it says an object is launched upward at 85 feet per second from a platform of 40 feet. So write an equation. Okay, that part I got. H equals negative 16t squared plus 85t plus 40. Okay, how high will the object go? And when will it reach its maximum height? Well, the key is to find the vertex. The vertex of the parabola gives me the time where it hits its peak and the actual value or the height of the projectile then. So we're going to use our formula. Instead of x, we have t equals minus b over 2a. That's the x-coordinate of the vertex, and that'll give us the time it hits the top. So that's minus 85 over 2 times negative 16, which is negative 85 over negative 32, which is about 2.66 seconds. So that answers the question, when. How high is what we get when we put that into the height function. So that's when it hits the peak. To find the height at its peak, we're going to do this. Negative 16 times 2.66 squared plus 85 times 2.66 plus 40. And I got 152.89 feet. Almost 153 feet. That's how high it goes. Now, another kind of question is, we could ask, when will the object hit the ground, or when will the object be a certain height? They want to know, when will the object be 100 feet above the ground? Well, that's a value of h. So we're going to put that into height. We get 100 equals negative 16t squared plus 85t plus 40. We have to solve this, and so hopefully you're thinking quadratic formula. But to do that, we got to subtract 100 from both sides first. We have to put it in standard form. So if I do that, I get 0 equals negative 16t squared plus 85t minus 60. If we do the quadratic formula on that, we get t equals minus 85 plus or minus the square root of 85 squared minus 4 times negative 16 times negative 60, all divided by 2a. 2 times negative 16. Well, to make a long story short, when you get that, you get two values. You get t equals 0.419 seconds, or t equals 2.24. This value is when it hits 100 feet going up, And this value is when it hits 100 feet going down. Turns out there are 2 times where it's 100 feet. Once on the way up before it hits its peak, and once on the way down. All right, that's an amazing amount of math there, and really good math. So, time to practice it yourself. So you should be able to complete the worksheet on real-world parabolas in Google Classroom. As always, submit photos of your work in Google Classroom. And you can email me anytime with any questions you have. I'd be glad to help you. See you next time.